All right, let's look at the interval that we have an unknown population standard deviation. This is the important part. If you do not know the population standard deviation, then you typically use a t-test. Use technology and the given confidence level and sample data to find the confidence interval for the population mean. So in other words, we want to find a low and a high point. What we're looking for is, this is our mean, and we want to know these low, and in this case they're going to be t-values for 99% confidence. Alright, so this is a weight loss on a diet. We want 99% confidence. The sample size is 41. The sample that was taken, the sample mean, is 4.0 kilograms. And the sample standard deviation, okay, because we don't know the population, so this is S instead of the sigma, is 6. So how we construct a confidence interval around the mean is we do the minus and the plus error of our sample mean, where the error is our t-stat times the standard deviation over the square root of the sample size. So this t-stat now requires using a t-table instead of using the normal distribution z. So again, I have all my information here and I want to construct. So what I'm going to look up in the t-table, I need my confidence and I need my degrees of freedom. Where the degrees of freedom is just 1 minus, or I should say the sample size, minus 1, so 1 less than the sample size. So I need the 99% and I need my degrees of freedom. So if I look here, I see in this column, this is my t-table, the degrees of freedom, 40. If you end up with a value that's not exactly in the table, you just pick the one closest, and I'll also comment here on how you can do this with your calculator to get exact values. But remember, this was 99% confidence, so that means the alpha is 100% minus 99%, or in decimal, 1 minus 0.99, and that's why I'm looking up 0.01 at 40 degrees of freedom, and I get my t statistic 2.704. So this is my critical value. So now I plug this in, I plug in my standard deviation, and I plug in the square root of my sample size, and I get my error. So now to set up my confidence interval, I just simply do my sample size minus this size plus that value, and this gives me my confidence. Now, one thing you ought to make sure of is when you do this confidence interval, 1.3, just for sake of, feeling like, does it seem like it's right? Certainly this value should be in here. Okay, because if this value is not in here, then you probably did your calculations correctly. So just be sure your sample mean is within this interval. Just a little check to make sure you didn't do a miscalculation. Is the confidence interval affected by the fact that the data appear to be from a population that is not normally distributed? Because typically if we have a sample size greater than 30, we can use a normal distribution. So the sample size is definitely large enough that we could have used a normal test.